I wanted to take you on a tour of the GIS workflow specifically so you can get a better sense of what you're doing in qGIS if you're working on that team. So the first thing you're going to need are the GIS files that exist at Vermont Open Geodata portal for your jurisdiction. So let's pretend you are working on Sandgate. So you're going to type in Sandgate zoning and you'll say, oh, I typed too much. Let's just try Sandgate. There we go. Sandgate Vermont zoning data is what we're looking for. There's also overlay zoning districts, but let's just work with the base districts first to get a sense of what they look like. So once you open up that page, you're given choices for the different formats of the file that you might use. I usually go with the GeoJSON. I download that because that's typically what you would need to upload into the National Zoning Atlas Editor tool. So let's download that. And then you would open your qGIS and you have this blank workspace over here that has no layers in it. Ignore all this other stuff. This is my stuff. So if you bring that file up, here's our Sandgate Vermont zoning data GeoJSON, and I'm going to move it into the layers workspace. This is what Sandgate's zoning would look like. Now the first step that you're going to want to do, and I do this all the time just to sort of familiarize yourself with what the zoning data looks like, is open up that attribute table, which you can do by right-clicking the Sandgate Remote Zoning Data link here and then going to the attribute table to see how things are labeled. So these are usually the abbreviated abbreviated district names for each of the zoning districts within Sandgate. So you've got a Forest 2, you've got a Forest 1, you've got rural residential, and there's a typo here, rural residential. So it's going to look like you have two different zoning districts, but they're actually the same district, and you can tell that because the initials, the abbreviations are the same, RR. So that's just a typo in terms of the way that it's described in long form. But really, we're going to say, okay, what are the distinct districts in this area, and do they have more than one part? So we have, for example, here you've got Forest 1, Forest 1, Forest 2, and I can see also there's an issue here where you have a F1, but it's attributed to Forest 2. So there may be real issues with this file. So this is going to take some careful work, but you at least know that in general, you've got a Forest 1 and a Forest 2 district, a rural residential district, and that looks like that's about it for Sandgate. So, and it looks like you have more than one row for each of those. So you've got more than one Forest 1 polygon, which we can take a look at here. So I'm going to do something which is called working with the symbology tool. So if you right click it again and you select properties, you can go to symbology, which is this side on the navigation bar, and we're going to do a categorized symbology on district name. I think they called it note was the name of the column. So we open up the notes and we're going to classify all of them. Oh, maybe it's not note. Hold on. Let's try district instead. Try classify by district. Oh yes, I would like to delete those others. Then I say apply. We can close this. And you can see that you've got districts that have more than one polygon. So this green polygon is closed, but there's another closed green polygon down here and another one up here. So that's sort of like multiple rows of data right now, and we want to merge them into a single row that represents that whole green district. And the question of how we merge it really relies on, number one, sort of the correctness of the data. So knowing that all of the Forest 1 districts, for example, are appropriately labeled F1 is important. And then also knowing that that there isn't another way of uniquely identifying each district is important. So sometimes you'll get a file where you have form-based code is how they identify it in the notes section, and then there's a second field that will tell you this is form-based code 1, form-based code 2. So you need to figure out what's kind of that uniquely identifying key, and then you're going to merge all of those rows on that data. So one step that I'm not going to cover here is georeferencing, which is really, really important, but Bill Hegman is going to create a secondary video that will go over georeferencing for you. But let's just take a quick look at what the official zoning map looks like. Here's Sandgate's official land use plan, map 8. It's in their regulations, and you can see it looks fairly similar to what's happening here. They look like they've got similar polygons, and what you would do with georeferencing is identify anchor points on the two maps and line them up on an OpenStreetMap to make sure that the polygons in our shapefile actually match the polygons that exist on this official static PDF map. So I will not go through that step. Let's just pretend, let's assume that this file is correct and that it is lined up with the official zoning map. And if it were, you would say, okay, I want to merge all of my polygons into single multi-polygons. So you won't have these island districts. Each one will have one row that represents it. And I'm going to, again, check that attribute table to see what was the uniquely identifying, I think it's zone. Zone is the one that uniquely identifies the district that we're in. And it also doesn't have these kind of typos, but you can fix the typos. So if you go into the attribute table, you can toggle into editing mode and make sure that this is rural residential, that it's correctly identified. And if you knew, for example, that this was not Forest 2, but it is Forest 1, you could change that to Forest 1. If you knew that it actually is Forest 2, you could change this to F2. But we're not going to do that right now because I haven't geo-referenced. I'm not 100% sure, but I do see another typo down here. Forest 2 should definitely not have an A. So I'm going to fix that, close my attribute table, and I'm just going to now dissolve those multi-polygons into a single row each, which identifies the unique layer. So I'm going to use the Mimi GIS group by tool. You don't have to use this. You can use the dissolve tool, but I like this one. And what I do here is I would say I want to group the fields by, I think we had called it zone. Here it is, zone. Okay. And then I want to dissolve the geometry. Always make sure you click that box. If you don't click it, you won't get what you want. And you run it, and it says, okay, now I have a new layer. So this was the original layer here that I pulled in from the GeoJSON, and this is the output layer after I had just dissolved the geometry. So let's take a look at the attribute table for that layer. And you see it only has those three districts. So it doesn't have all those extra ones because this F1 represents every polygon that is in the Forest 1 district. This one represents every polygon that's in the Forest 2 district, etc. So once you've merged them, we're going to use the topology checker tool, which is this button over here. And we're going to take a look to see if there are any topology errors. So you're going to say, which layer am I looking at? I'm looking at the SQL output layer, and I want it to not have gaps. So I'm going to add that rule. I want the SQL output layer to not have invalid geometries, add that rule. And I want the SQL output layer to not have overlaps. Those are the three rules I typically work with. You say, okay, and then you run the topology checker, and it says to you, oh no, I found 392 errors. Ugh, and you just want to give up. But don't give up. Some of these errors might be really easy to zoom in on and fix, but some of them may be more complicated. And when you have as many as like almost 400 errors, I recommend that you try using one of the different sort of pre-packaged approaches. So I'm going to try v.clean and see what it does for me. This is in the grass package. So if we pull up v.clean, I'm going to try running it and see what happens. Maybe it'll get rid of a bunch of those errors, and maybe it won't. Maybe it'll create new errors. We'll find out. So now, one thing I always do once I run a new, when I create a new layer, is I try to just like toggle between that layer and the last layer to make sure that none of the boundaries moved around on me, especially if you're using a package like v.clean or v.generalize. Sometimes the ways that it fixes things is by moving the boundaries such that they no longer align with the actual district, and you don't want to have that happen. So here we have basically the same, it doesn't look like we have a whole lot of change from one version to another. And so I'm going to take a look and see if maybe I can run that topology checker on my new layer. So I'm deleting all three rules, and I'm going to go to the cleaned layer, and I'm going to say the same thing. No duplicates, no gaps. I'm sorry, not no duplicates, no gaps, no invalid geometries, and no overlaps. And let's see what happens. Okay, and I'm going to run it again. And I'm going to say the same thing. No duplicates, no gaps, no invalid geometries, and no overlaps. And let's see what happens. Okay, and I'm going to run it again. Okay, and I'm going to run it again. And let's see what happens. And we got to 390 errors, so it only got rid of 2. That's not an amazing outcome. But generally this is, I must have picked a really terrible file because typically you don't get anything quite that bad. But in any event, you can then go in and try other prepackages. So I would try v.generalize, for example, and see if that'll fix it, make it a little bit better. Gonna run and say, let's see what happens. All right, see, now this is what I'm talking about though. You see there's a big difference in this in the output of v.generalize versus v.cleaned. It's moved a boundary significantly. So if I got rid of that, you would see that underlying it, the shape of the jurisdiction's boundaries have changed significantly. So that's not ideal. We don't want that to happen. If you look at right here at this particular district, it's really changed its boundaries in order to fix those validation errors. So this is not what you want to use to fix Sandgate, for example. So, but let's just take a look and see if it was able to at least fix the validation errors, just to get a sense of what the power of that particular tool is with this file. Generalized, no gaps, generalized, no invalids, and generalized, no overlaps. Let's see what we get. And we run it again, and we got 410 errors. So welcome to GIS. It is very nitpicky and very difficult, and depending on the file you start with, you'll either take very little time or you'll take lots and lots of time.